Dear students, this is Someshwara CSR. Now we are discussing the second paper on 24th January. Now let's go to the paper discussion. First one is based on the given data, the strong reducing agent. So we know that SRP values, standard reduction potential, is negative, act as a reducing agent. At the same time, SRP is positive, they are oxidizing agents. More negative SRP act as strongest reducing agent, then more positive SRP act as, that is, oxidizing agent. In our electrochemical series, strongest reducing agent is lithium by lithium, that is minus 3.05 is a volt. Strongest is fluorine, that is PT F2 by F minus, this value equal to plus 2.87 volt. Clear? Now one more important point is SRP value is calculated based on SRP. This is a sum of enthalpy of atomization. Next one is ionization enthalpy, that means IE1 plus IE2 so on, plus heat of hydration. These two values are positive values. This is negative value. If this value is dominated, is a positive values. Hydration enthalpy is dominated, that is a negative value. Clear? Now we are coming to the point. In this one, here this is, we want reducing agent. We require negative. Here only one negative. So in this one, reducing agent means involved in oxidation. That means E0 Cr plus 3 by Cr is equal to minus 0.74 volt. Okay. Now in SRP, negative value is goes to this side. If positive value, this side. Okay na? Now in this one, Cr gives rise to Cr plus 3 plus 3 electrons. This process is oxidation. Then this is called reducing agent. Clear? Therefore, strongest reducing agent is this one. Okay. For suppose Cr plus 3 by Cr plus 2 minus 0.41 volt, then cobalt plus 3 by cobalt plus 2, here plus 1 point, then 5, this is 97 volt is given. At that time, here negative SRP is there, negative. So this is changes to this side. Positive is there, this to this one. That is clear. We want this is the negative, lower to higher. Okay. Now we go to the second one. Okay. Given. What is the given? Here T half and initial concentration. T half and initial concentration. According to first order reaction, K1 equal to 2.303, then by T log A0 by A, that is initial concentration after T time, or this if T equal to T half, then A equal to A0 by 2. We substitute here K1 equal to 0.693 by T half, or T half equal to 0.693 by K1. So initial concept for first order reaction, this is for first order reaction. First order reactions. Okay, now for first order reactions, then here this is given different conditions. Here we go to this one. This is initial. This is a 0 initial concentration and half-life time. There is no relation. This is the first order reaction. Is the correct. Next one. Then graphical representation is, here we take this one. This is L log K1 T by 2.303 equal to log A0 concentration by A concentration. Okay, na? Then is the concentration. Now here this is or K1 by K1T by 2.303 equal to, take a reverse, that is minus log A concentration by A0 is nothing but here K1T 2.303 equal to minus log R concentration by R0 concentration. This is a negative slope. This is a positive slope. That's why this is the wrong one. Clear? So, what is the option? Statement 1 is correct. This is the option. Okay, na? Now, here we want to convert aniline to, what is that? Ortho bromo aniline. Generally, we know that this is subjected to acetylation. After that, we get a bromination. Then we get orthopara. Next, that is this one. This is. In this one, you get, what is the major product? This is a major product, para. But we want ortho. How to get? You take first one. This is wrong because aniline is treated with Br2 in the presence of FeBr3 electrophilic substitution reaction, ortho and para. You get two products, BH2, then NH2, here Br. This is major product. Clear? Now you are going to, aniline is taken, is treated with concentrated H2SO4. We get a salt, NH3 plus HSO4 minus is the salt, is the stable. Then it is heated at 180 to 200 degree Celsius. Then this is NH2SO3H, sulfanic orthosulfanic acid. Is it clear? This is up to here. Now this is. Now what the next one is? This is treated with acetylation, CH3 C double bond O, CH3 C double bond. Then NH CO, that is minus CH3 COOH. Next one is COCH3. Okay. Then this is SO3H. This part. This is completed. Now this is treated with Br2. Then we get NHCOCH3. Then this is SO3H and this is Br. Clear? Because this is a para position is already blocked. Okay, na? This position already blocked. Is blocked. That is why now is this part and H2 and heated. Then what is going on? This is removed out. Then this is removed out as a H2SO4. Then this is SO3 plus this H2O gives rise to H2SO4. Then remaining part is here Br. This is NHCOCH3 and after that you are getting Na, which is nothing but neutralization of this one. This is NH2 followed by NaOH. This is acid and base is neutralized to form a water. That water is combined with this one to form this part. Okay, na? This is the answer. If you take this one, what happened? Direct. We get a in this one. This is para is major product. What you practice in NCERT textbook in our classroom, this part, but is given in reverse way. Okay. Now, for a hydrogen atom is a very regular and routine questions in our JEE Main. Hydrogen atom, uni-electron system, multi-electron system. For uni-electronic system, then energy of the orbitals depends on two factors. That means quantum numbers. Is for uni-electronic system, uni-electronic species, that means uni-electronic species like H, helium plus, then lithium plus 2, so on, is depends upon only principal quantum number, that is n, does not depends on. For multi-electronic system, multi-electronic species, then energy depends upon both N and L. Okay, na? So here this one. Now we are going to the uni-electronic system. We are going to this side, energy is increases. Is the first orbit, the second orbit, this is the third orbit, okay. So this is the energy order, then orbitals. Now this is 1s, here this is 2s, 2p, next this is 3s, 3p, 3d. Therefore, for uni-electronic system, for hydrogen atom, energy order is 1s less than 2s equal to 2p. That means px, py, pz, anyone. Okay, na? Either px, py or pz. Then 3s, 3p and 3d. Okay. And now we are going to that. This is 4, these two are equal energies, remaining 2. That is nothing but here 3p, here. This is in this one, here px, py and pz. In this one dxy, dyz, dzx, dzx, dx square minus y square and dz square. Here all are equal. Okay. Now what is the option? 3px, 3 d square, x square minus y square, dz square. What are those? This one, this one, this one. Okay, these two are equal, these three are equal. So what is the option? BCD, BCD or AE, A and E only. What is that? From the answer given below, A and E only. Choose the correct answers. What is it given? For hydrogen atom, orbitals with lowest, okay, here lowest energy compared to here 4s you take, here you take, here this is 4s, 4p, 4d, 4f. Compared to this one, lowest energy means we require this part. Okay, na? Highest energy is given, these two are equal. Okay. Option is, what is that? B, C, D. Is it clear? Is a mention lowest energies are. If highest energies are given, or the option is 1. Clear? Okay. Now, a very simple question. We know that for organic chemistry, organic compounds, carbon involved in 3 type of hybridization, 1, 2 and 3. Due to lack of d orbital, these are sp, sp2 and sp3. Okay, na? In carbon compounds, carbon involved in only 3 type of hybridization because non-availability of d orbital. Okay, how to identify this one? Here pi bonds 2, okay, change the color, and then pi bonds 2, this is pi bonds 1, pi bonds 0 for a particular carbon, then that is a sp3. So here we need then sp and sp2. Sp means this one, sp2 means this one. Clear? Therefore we are selecting. Okay. Then we go to this one. Is the double bond is there? This is sp2. Here double bond sp2. Only asked carbon atoms, not oxygen. So is sp2. This is sp2. This is sp2. Okay, na? How many are there? 1, 2, 3, 4, 5. So sp2 5. Clear? Now you are going to the then next one is, you go to this one. this is a triple bonded carbon, sp, this is sp, this is sp. We want only carbons, so these are 3 comma 5. So option is this one. Clear? This kind of simple questions are asking general concept, important model and simple questions. Next one. Here, which of the following mixing of 1 molar base and 1 molar acid leads to the largest increase in temperature? Is a neutralization process. In neutralization, acid plus base gives rise to salt plus water and heat. This is a neutralization. Therefore, heat is directly proportional to temperature. Then this is the heat of neutralization for strong acid versus strong base. This value equal to fixed value minus 13.7 kilocalorie per equivalent or minus 57.1 kilojoule per equivalent. Okay, na? Remaining is any one of the acid is weak or any one of the base is weak, then heat of neutralization is lower than this one, because either weak acid or weak base, ionization is endothermic process. Okay, now in this one, here this is HCl, this is a strong. Either possibility is there. Here weak acid strong is wrong. This is strong acid versus strong base. Now this is weak acid versus then weak bases, sorry, strong base. Now here this is HCl is a strong acid versus strong base. Okay, is a possibility is there. This is then weak acid versus strong base. So out of 4, 2 options deleted. Now here one more important point is heat of neutralization. In neutralization process, acid and base concentrations are unequal. Heat of neutralization depends upon limiting reagent. What is the limiting reagent? Least concentrated reactant. So then if concentrations of acid and bases are unequal, then heat of neutralization value depends on limiting reagent. Depends on limiting reagent. Limiting reagent is nothing but least concentration. Okay, na? So we are going to the molarity equal to N by V into 1000. Therefore, normality equal to MV by 1000. Okay, na? Now here acid and base molarities are equal. Therefore, we are going to the first one, HCl plus NaOH gives rise to NaCl plus H2O. Then heat of neutralization. This is one equivalent. Then heat of neutralization value I'm taking, okay, X, that is our choice. That is 13.7 kilocalorie per equivalent. So here nth factor equal to 1, mole equivalent, both are same. Now what is the given condition? Then option 1, What are the moles? That is 1 into, what is the volume? 30 by 1000 equal to 30 millimoles. Then this also 30 millimoles. 30 millimoles. Next option here, both are same. Now third one is a 50 millimoles. 1 into 50 by 1000, that is a 50 millimole. Next one is, this is 20 millimoles. 1 into 20 by 1000. This is 20 millimoles. So this is LR. Here there is no limiting and excess reagent. So here this value is 13.7 into 30 millimoles into 10 power minus 3. Here 13.7 into 20 into 10 power minus 3. So this is the answer. Clear? Need not to solve, just for your clarity I am explaining. If acid concentrations are same, is okay. If concentrations are unequal, least value considered. That is a limiting reagent. This value is a 20, this is a 30. So 30, 30, 50, 20 is a limiting reagent. So we are considered for 20 millimoles. Okay, na? Is it 20 millimoles? Okay. Option is 1. Get a point? Now, statement 1. Experimental determination determined oxygen bond length in O3 is found to be same, and the bond length is greater than that of double bond but less than that of single bond. So right, because here we go to O3, then is the resonating structures are there. And then one more resonating structure. And then here O single bond, here this is double bond. Then generally OO single bond length is OO single bond length is 1.48 angstrom unit. C double bond O value equal to 1.21 angstrom unit. But here O bond in O3 is 1.28 angstrom unit due to resonance. Then here, what is the resonating structure? Resonating structure is O that is okay, na? So this statement is correct. This statement is correct. What is the second statement? The strong lone pair repulsion between the oxygen atom is solely responsibility for, no, this is not a correct. This is a responsibility for resonance. Okay, this statement is wrong. So option is, first statement is, this is the option. Clear? Its bond angle is around, this resonance hybrid, around 117 degrees. Clear? Its bond order equal to BO. Its bond order equal to total number of bonds by surrounding atoms. 3 by 2 equal to 1.5. This is okay, na? Its formal charges are, this is here 0, this is the plus 1, this is minus 1, this is minus 1, is a plus 1, is a 0. Okay, okay, na? Now here Find the compound A from the following reaction of sequence. Then here A, aquaresia, B, potassium nitrate, ammonium hydroxide and acetic acid. We get a yellow precipitate. Here important point is here aquaresia. Both are dissolved in aquaresia, not only COS. Then NIS, these are soluble, but these are soluble only in aquaresia. Not only this one, cobalt sulfide and nickel sulfide also soluble in aquaresia. But here only cobalt metal is combined with this one to form yellow color precipitate. So this is the option. Then COS, cobalt sulfide, aquaresia, HNO3 plus 3 HCl gives rise to then COCl2 plus NOCl nitrosyl chloride plus H2O, how many hydrogens are there? Here 2 plus sulfur. This is the first step. So this is B. This is A. Now COCl2 plus KNO2 plus what is that? CH3 COOH in the presence of basic medium. Then K3 CONO2 taken 6 plus KCl plus CH3 COOK plus here what are those? This is NO plus H2O. And then this is here it takes 7 and 2. This is 2, here 2. Okay. Then this is yellow precipitate. Yellow. What is the name of IUPAC name of this one? Potassium hexa nitrito, that is N. Okay. Cobaltate three. That is, this is yellow color. Okay, na? Okay. 7. Here 6 plus 1. Okay. Is okay now? So option is this is. So this is somewhat tough because we have a good idea about the what is that qualitative and quantitative analysis. You are able to give this kind of questions. Here questions are confused only in two regions. One is biomolecule, second one is qualitative and quantitative analysis. We can focus about these two topics for by-hearting purpose. Practice properly. Okay. Now, simplest question. H2, these are the reactant, this is the product. Two reactants. Here anywhere you go to reactant means a downward, product is nothing but upward. Here how many reactants are there? Two reactants are there. So these are the reactants, this is the product. Two reactants, one product. So option is this one. Clear? There is no other content. Is it downward? This is from 0. Next one. Then what is the spin only magnetic momentum? Spin magnetic momentum mu equal to under root n into n plus 2 bm. Bohr magnet turn. Here n equal to number of unpaired electrons. Number of unpaired electrons. Number of unpaired electrons. Clear? Now we go to here scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. This is 21. And this is first one is here titanium, but this one is, that is argon core, then 4s2 3d2, then it changes to titanium plus 3. That means here these 2 electrons in this 1 electron is removed, we get 3d1 configuration. That means n equal to 1. 1, 2, 3, 4, 5. Only 1 is there, 1 electron. Okay. Therefore, here mu equal to under root 1 into 1 plus 2. Here is root 3 is equal to 1.732 bm. So, for this one, this is 3. Clear? Now, second one is, what is that? Vanadium. What is the vanadium? Vanadium atomic number is 23. Argon core 4s2 3d3. We require vanadium plus 2. Vanadium plus 2. So, loss of 2 electrons. Here d3 configuration. What is the n value? 1, 2, 3. Okay, na? 1, 2, 3. N equal to 3. Therefore, mu equal to under root 3 into 3 plus 2. Root 15. Root 15 is nothing but 3 point. Root 16 is nothing but, that is a 4, less than 4. That means 3.87 bm. That is here 1. Okay. Now, next one is nickel. Nickel, what is the Z value? 28. Argon core 4s2 3d8. Then nickel plus 2. Therefore, what is the configuration? 3d8. 3d8 means here 1, 2, 3, 4, 5, 6, 7, 8. 2 unpaired electrons are there. This is 1, 2, 3, 4, 5. Here 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 2 unpaired electrons. These 2. So, n equal to 2. Therefore, mu equal to under root 2 into 2 plus 2. That means under root, that is 8. 8 means 9 means root 9 is a 3, is a less than 3, is a 2.84 bm. That is 2.84 is a 4. Next is scandium. The scandium is Z equal to 21. Argon core 4s2 3d1. Scandium plus 3. So, no d electrons. N equal to 0. Mu equal to 0. Dia is dia. So, that value equal to 2. 2. Option is 3, 1, 3, 1, 4, 2. Option is this one. Okay. Okay, na? Now, listen. This kind of questions never solved by systematic order. Okay, na? Just you can go to the verification of the compound. I explained the 2 model. Anywhere molecular mass of the compound is given, don't go to any calculation. We go to the reverse calculation. You can check the options. So here 132 molecular mass already given. So percentage of this one, what is the empirical formula, what is the molecular formula, is a time-based process in examination. Okay, I explained the two formats. So in this one, here we go to this one. First option is C4, that is a 4 into, this is a 48 plus 9 plus 48. Okay, na? So this is wrong. What is the value? 108, na? This is 48, 48 and 9. This is the 17, 25. Okay, na? 105. This is wrong. So this is wrong. Next one is, this already we know, glucose 180. This is wrong. Next, third one is, 72 plus 12 plus 48 is equal to, here 50, 60, 132. This is correct. This is the option. Okay, na? And this is 48 plus 8 plus 32 equal to 8. This is the 88. This is also wrong. Okay, this is the easiest method. Systematic order. What is the systematic order? Then percentage of carbon, percentage of hydrogen, percentage of oxygen, then oxygen. So then carbon, hydrogen and oxygen. Okay. Now what are the percentages or weight? What is the given? 54.2, this is 9.2, this is 36.6. Okay, na? Now mole ratio, mole, then 54.2 by, this is here 12, 9.2 by 1, 36.6 by here 16. This is 9.2, this is 2.28, and then this is the 9.2, this is around 4.51, then it's double, it's a half, then 2.28 is the least value. This is the least divided by least. Therefore, simple ratio divided by least. That means divided by least value. So this one by this one is a 2, this is a 4, this is a 1. Okay, divided by 2.28, here 2.28, here 2.28. Okay, na? Therefore, what is the empirical formula? Carbons 2, hydrogens 4, oxygen 1. Therefore, empirical formula equal to C2H4O. What is the mass of empirical formula? Empirical mass formula is, then empirical formula mass, that is 24 plus 4 plus 16. This is 44. Okay, na? Now, what is the regular formula? Molecular formula equal to empirical formula into N. Clear? That is C2H4O into N. N equal to molecular mass by molecular mass by empirical formula mass. 132 by 44 is a 3. So C2H4O into 3, C6H12O3. This is okay na? Don't go to this side. This is this type of question. Okay, is a anywhere in the given question molecular mass is given, directly we go to the verification to avoid this kind of calculation. Okay, next one is a very regular and repeated questions in exams. Then what is this one? The color of the complex compound depends upon nature of the ligand also. That is the theme of the concept. So here nickel NiH2O taken 6, here plus 2. Then this is aqueous solution. This is a green color. This is the green. Green is treated with EN, ethylene diamine. CH2, CH2, NH2, NH2. This is called EN, ethylene diamine. 1 unit is participated. You get a, this is NiH2O taken 4, En. Okay na? Then here plus 2 plus 2H2O is a bidentate ligand. This is pale blue. This is pale blue. Pale blue. Okay. Now this is this is a 2, here is a 2. Okay. Now this color is a blue or a purple color. Here blue or purple color. Okay na? Next one is the green, pale blue, blue. Okay. Next one is then this is En taken thrice, here plus 2. This is violet color. This is violet color. Okay na? So option is green, pale blue, blue, violet. This is okay. Now the condition and sequences of favorable of T2Z3 and EZ1 configuration of metal complex. Here then we know then here this is d orbital is splitting into 2 parts. This is dxy, dyz, dzx, dx square minus y square and dz square. Okay na? This is nothing but T2G, this is EG. Okay. Now here you go to here is given Here two type of categories are there. Two types. Then this is a D4 configuration. This is a D4 configuration. Totally how many electrons are there? 3 plus 1. Two possibilities. One is possibility 1 and possibility 2. One is weak ligand. Second one is strong ligand. Weak ligand is nothing but this is high spin complexes. High spin complex. Then this is low spin complexes. Name is low spin and high spin. Okay. Now weak field obeys Hund's rule. Here obeys Hund's or Hund's rule. This is oppose Hund's rule. Okay, what is the meaning of that? In this one, 1, 2, 3, 4 is obeys. That is T2Z3 EG1. Now oppose the Hund's rule 1, 2, 3, 4. That means T2Z4 EG0. Now is given this kind of configuration is given. T2Z3 EG1 configuration. That is why we are going to the weak field complexes. That means weak field, weak ligand and high spin. So option is this one. Clear? This is okay. Now identify the correct statements. Then OCH3. Then here A OCH3, this is plus R, okay na, and NHCOCH3, this also plus R, but compared to this one is a strong. Then plus R groups are called activating groups. Activating groups or orthopara orienters. Activating groups, or these are also known as orthopara orienting groups. Clear? So this is the correct statement. Okay na? Then next one, CN and OH, B. Here we go to the B. CN, this is minus R, is a meta orienting deactivating group or meta orienting group. And then what is the second one? OH is a plus R activating and orthopara orienter. So this is wrong. Now here third one, C minus CN, that is the same, minus R or minus M, deactivating group, meta orienter, and SO3H, this also same, SO3H. Then okay na, in this one cyanide is greater than SO3H, so this is correct. Next one, activating groups act as orthopara orienting group, this also correct. Halides are activating groups, no. Halogens, that is E. Halogens are two effects are there, minus X and plus R. This is dominated. This is a dominating effect. So halogens are deactivating than benzene. These are due to this one orthopara. This is deactivating group. Deactivating. That's why this statement is incorrect. Halogens are orthopara orienting groups and deactivating. Okay na? Minus I is minus I. This is minus I. Okay, na? So what is the option for this one? We required correct statements. A, C, D. This is the option. Okay, na? And now, then first ionization enthalpy of lead is greater than, okay. Now we are going to the, in simple concept is, here generally ionization enthalpy are expecting carbon greater than silicon greater than germanium is greater than tin greater than lead is the expected value, expected, but correct order is, correct order, carbon greater than silicon greater than germanium greater than Pb greater than tin, just is a reverse due to poor shielding of d and f orbitals and large size of element. Okay, so this is ionization enthalpy, this is atomic number, here this is carbon, here silicon, this is germanium, this is the tin, this is the lead. So is not exact values, this is around 86, this is around 780, this is around 760, is approximate value, I am telling that kilojoule per mole. Next, this is 715, this is around 718. Okay, na? So this, okay, na? What is the first statement? First ionization enthalpy of, this is IP1 values. Then first ionization enthalpy of lead is greater than tin. This is correct. Okay. Next one is the first ionization enthalpy of, this is carbon, this is silicon, this is germanium, this is the tin, this is the lead. Okay. Now, what is that? The first ionization enthalpy of germanium is greater than silicon is wrong. Okay. Is clearly mentioned in NCERT, old NCERT textbook. You revise once. The next one. What is the given? Yes. Heat of formation of SO2 is required. SO2 gives rise to S plus O2 is a required equation. Is a solid. This is the gas. This is the gas. This is required equation. What is the delta H value? Then S solid. Okay. Then this is a sulfur solid plus oxygen 3/2 O2 gives rise to here SO3 gas. Okay. Okay, na? What is the delta H value? Is a common representation is given, it changes to IUPAC minus 2x value. What is the second one? SO2 gas plus half O2 gives rise to what is that? SO3. What is the value of this one? Delta H equal to minus Y. Now we are going to, then that is the subtraction. Now this one is a cancel. S solid plus O2 gas gives rise to SO3 gas. Therefore, delta H required equal to Y minus 2x. Y minus 2x calories. This is the option. Okay. It's okay. Now is a direct question. And then A is A. Cyanides are subjected to tin HCl. We get amines and then followed by hydrolysis, acidic hydrolysis. This is conversion of cyanide to aldehyde. That is what is that? Stephen reduction. This is Stephen reduction. Stephen's reduction. Next, this is chromyl chloride Itard reaction. This is Itard reaction. Now, this is Itard reaction. Now, this is acid chlorides reacts with H in the presence of palladium barium sulfate. You get a aldehyde is a Rosenman reduction. Where is the Rosenman? This is a Stephen reduction is where the Stephen reduction is the 4. Is the 4. This is acid chlorides. That is the Rosenman. Rosenman's reduction. So this is what is the Rosenman reduction is a 3. And this is Itard reaction is the 1. This is Gutterman-Koch reaction. Gutterman-Koch reaction. So where is the Gutterman-Koch? Is it 2? So option is A4, B3. Okay, option is this one. It's a direct question. Now, the structure is the structure of the major product when reacts with this one. Here, benzene attached with halogen is not involved in either SN1 and SN2 reaction due to plus R effect. That means a partial double bond will be formed between carbon and halogen. So this one is not removed, this one is not replaced. So this halogen is removed, we get a positive charge. Now here cyanide ion is there, is a covalent compound, that is Ag C triple bond N. This lone pair is donated to that one. So this group is removed, is replaced by, that is the NC. Option is this one. Okay. Here not Cn. If you are using KCN, this is a possible. If you are using, it gives the NC product. Then we know alkyl halide treated with AgCN, we get NC. Then KCN, we get RCN. This is a major product. Major. This is a major. Similarly, here is a treated with KNO2, you are getting RONO. Then you are using then N double bond O minus. Okay, na? Now this is a K plus. Then N double bond O O, this is AC. Now we are getting R is the NO2. Clear? This is, we know this one. So option is this part. Okay. This is K plus plus Cn minus. Then K plus C triple bond N minus. Okay, na? If it is KCN is added, you get the directly cyanide. We are using this is, that is N is attached. Okay. Now, so you can practice. That's why previous already I told. You get a problem in two areas. One is biomolecules. Second one is qualitative and quantitative analysis. So here simple questions from the directly asked from the NCERT, and then by hearting concept. So here option is, here one more simple one is, you take a thiamine. Thiamine is methyl group is there. Methyl group is not there. That is called uracil. Here is a methyl group is there. Here methyl group. This is. Here methyl group is not there. That is called uracil. Okay. This is uracil. That is the adenine and guanines are two rings are there. Here is a two rings. In UTC, uracil, okay, na, thiamine and cytosine. Then AG, adenine and guanine. These two are two rings are there. Two rings. These three are single ring. So two ring compound is this one. A. This is option. Okay. This is this one. This one only one variation. What is that? This is methyl group is there. That is a thiamine. Uracil, there is no methyl group. Okay. Now, this is very, very simple and important question. Ionization enthalpies are given. 1, 2, 3, 4, 5 is a given. So, sudden jump between 1 and 2, here first ionization enthalpy, second ionization enthalpy, third ionization enthalpy, fourth ionization enthalpy, fifth ionization enthalpy, these are given. 1 and 2, here gap is there, this is here, this is the first group, this is the first group. First gap, second gap, third gap, fourth gap. Clear? 1 and 2, sudden jump, hike, value is a sudden hike is there, this is the first gap, first group. Here is there, that is called second group. This is the 13th group, this is a 14th group, this is a 15th group. Clear? Sudden jump between 1 and 2, 1, 2, 3, 4, 5 given values. This is first group, this is second group, these are the values. Then this is group number, is a 13th group, this is the 14th group, is the 15th group. Now here sudden value hike is there in this one, sudden hike is there. Then sudden hike is there, that is first group element. 1 and 2 gap is there, is the first group. Okay, na? Or otherwise you take like this, it's your choice. Sudden hike is the first group, then second group is the third. Now here what is that? 800, this is 800. Second one is 2427. Okay, na? Roughly variation, you can need not to measure, just you observe. Then this is 3658. Next one is 20, this is 3000. This is 25,024. That is. Then this is 32,000. 8 to 4 is given. Where sudden jump is there? Sudden jump is in here. That is big hike. Okay, na? Now, what is this one? This is a 13th group element. 13th group element. This is the option. Clear? Sudden jump between 1 and 2, first group. Second and third is a second group. Okay. Now, here in previous video we discussed about the questions. Same Jan 24th morning section, and this is the afternoon section. These questions are very simple questions are given. Here 71, here 72, here 73, here 74 and 75. All questions are very simple questions. But in last paper is a very complicated questions are given. I already make a video. Okay, na? You observed. That is why now observed and normal. We know that Vanta factor equal to here, then Vanta factor I equal to observed colligative properties by normal colligative properties, or I equal to normal molecular mass by observed molecular mass. Okay, na? That is. So here, sir, how to identify? No, need not by heart. Here this is ionization. Due to ionization, number of ions increases. That's why I value greater than 1. That's I value higher than 1. Clear? Due to association, number of units decreases. I less than 1. That's why here is a association. This is a ionization. Number of I value always higher than 1. That's why higher by lower. Sir, I get a formula. This is observed by normal or normal by observed. I forgot what is a nothing. So here is ionization. Higher value by lower value. That's it. This is association is given. Then lower by higher. Simple logic. Clear? Now, this is ionization. Higher value by lower. That is why here is a given. Observed and this is. What is the normal value? Normal value equal to 164 by 65.6. What is the logic in the numericals? Higher by lower. Vanta factor I equal to higher by lower. Then dissociation or ionization. Okay, na? If this is association is given, I always less than 1. That's why given two values are given, lower by higher. Now this value equal to 2.5. I. Okay, na? Next, for the second step, second one is here we take mx2. mx2 is given. mx2 then gives rise to m plus 2 plus then 2x minus. Clear? Now here we go to what is the value? This is 1, or for the formula of Vanta factor? I equal to 1 plus greater than 1 alpha into n minus 1. What is the n value? How many ions are there in the solution? Here n equal to 3. That means number of ions in aqueous solution. Therefore 2.5 equal to 1 plus alpha into then 3 minus 1 is equal to 2.5 or 1.5 into 2 alpha. Therefore, alpha equal to 1.5 by 2, 0.75. Therefore, percentage equal to 75%. Okay, na? Percentage of alpha equal to 75%. Option is 75. Clear? It's okay. Next, question number 72. The possible number of stereoisomers for 5, 1, 2, 3, 4, 5. 1, 2, 3, 4 and 5. Then 5 phenyl. Next, 4 ene, 1 ol. So CH3, here hydrogen, this is H2, here hydrogen, this is. In this one, stereo center is nothing but not only optical, geometrical also possible. So here this is one chiral center, this is one more stereo center. Therefore, total number of or possible number of stereoisomers equal to 2 power n. Here n equal to number of chiral carbons, number of chiral carbons and number of double bonds which obeys conditions of geometrical isomerism. What is the geometrical isomerism? Double bond, both sides are unequal is a double bond, this side unequal, this side unequal. So here n equal to 2. 2 power 2 equal to 4. Okay. Option is 4. Next one. In kinetic, one of the important model. Compared to this in JEE advanced level, this is very important. Now, here K1 is given. K, according to Arrhenius, K equal to A into e power EA by RT. This is. Now, we consider a complex reaction in 3 stepwise constants, stepwise rate constant. This is overall rate constant. This is overall activation energy. Now, K1 equal to now here and then stepwise is the K1 A1 activation energy 1. Then is it 2, here 2, this is a 2. Here 3, this is a 3. Now, what is the given condition? Given condition is what is the given condition? K overall constant is equal to under root K1 K3 by K2. This is okay. Therefore, what is the K1 value? This is what is the overall equation? This is overall equation A overall equation equal to into e power EA overall by that is RT. Okay, no space, that's why I am using O only. Okay, here under root what is that? A1 e power EA1 by RT. Okay, na? Into A3 e power EA3 by RT divided by A3 into e power EA2 by RT. Clear? And then next one is this equal to A1 A3 by A2 into e power minus EA1 minus EA3 plus is go to up, that is EA2 by RT under root. Is okay? This is nothing but A1 A3 by A2 whole power half, and then this is e power minus EA1 plus EA3 minus EA2 by RT whole power half. Okay, na? This is now what is this value is nothing but by this is here 2 e power minus x power 1 by a equal to minus e power x by a. Okay, na? Now based on this one, so here activation energy from these two sides both are equal, these two are equal, these two parts are equal. Therefore, activation energy overall these two are equal, these two are equal. Okay, now is equal to then EA1 plus EA3 minus EA2 by 2. What is the reason? E power EA overall by RT equal to e power EA1 plus EA3 minus EA2 by then 2RT, that is okay, na? We are equalize these two factors, this part including this one. Okay, now what is the value? This is EA1. What is the EA1 value? 60 plus 10 minus what is the value? 60 by 2. is equal to 70 minus 40 by 2 equal to 20 kilojoule per mole. Clear? This answer is 20. Okay, na? Next one. Here, hydrocarbon X with molecular mass 80 gram per mole and 90% of carbon has degree of unsaturation. So, what is the degree of unsaturation? Degree of unsaturation means the number of hydrogens less when compared with relative alkane is degree of dissociation. 2 hydrogens are less is able to form one degree of unsaturation. For example, I am taking C2H6. C2H6 ethane is a saturated compound, alkane. Clear? Then here 1, 2. Okay. Now in this one C2H4 is taken. Given compound is compared with relative alkanes, how many hydrogens are less, that is divided by 2 is called degree of unsaturation. How many hydrogens are less compared to relative alkanes? So 2 hydrogens are missing, we get a 1 pi bond. That is called degree of unsaturation. So here how many hydrogens are there? 4. Here how many hydrogens are there? How many hydrogens? Then 4, difference is 2. 2 hydrogens means is equal to 1 pi bond, double bond. That's why CH3 single bond CH3, this is CH2 double bond CH2, that is. So what is the degree of unsaturation for this one? 1. Then for 2 hydrogens value is 1. Okay, now 1 pi bond. Du equal to how much is a 1. Next one, we take C2H6 is there or C2H2. Compared to this one, how many hydrogens are less? Then 4 hydrogens. Number of hydrogen 4 means then 2 pi bonds. Then here CH triple bond CH. What is the Du? Du equal to Z2. Similarly, C6H6 is there. Then here a relative alkane. Then C6H6. I want what is the degree of unsaturation. What is the relative alkane? C6 double plus 2. What is that? 14. How many hydrogens are less? 6 to 14. How many hydrogens? Here 4 plus 4, 8 hydrogens. 8 hydrogens less. 8 hydrogens are less means divided by 2. What is the Du? That is 4. Okay, na? This is. Okay, one more formula also there. What is the other formula? Du equal to 2n plus 2 minus number of hydrogens plus number of halogens minus number of nitrogens. There is no importance of oxygen. Never counting the oxygen. Divided by 2. Okay, na? So here n equal to number of carbon atoms. Here n equal to number of carbon atoms. Okay. So here apply. I am taking this one, benzene. Here what is the Du value? Du, how many carbons are there? Carbons 6. Then this is a 14 minus how many hydrogens are there in this one? I want Du of this one as per the formula. Du. Then how many hydrogens are there? 6 plus halogens 0, nitrogens 0. by 2. That means 8 by 2 equal to 4. Both are same. This is a du story. Okay, na? Clear? Now, we are coming to the carbon compound. What is a compound? So, percentage of carbon. That means I want weight of carbon in organic compound, in hydrocarbon, is equal to weight. I am talking about the weight. Weight equal to how much? 16. How much percentage is there? 90 by 100. That is 0 cancel. 8 into 9. This is 72 grams. Is it clear? 72 grams. 72 means I am writing 4 into, that is 6 into 12. 6 into 12 means how much? 60 plus is a 12, 72. That means 12 means 1 carbon. No? This compound has, that means compound has 6 carbons. That is 6 carbons. Okay, na? Now, weight of hydrogen in hydrocarbon. Hydrocarbon. That means is a 90%. Percentage of carbon equal to 90% is nothing but percentage of hydrogen equal to 100 minus 90 equal to only 10. Clear? Therefore, 80 into 10 by 100. This is 8. So, 8 grams. 8 grams means 8 into 1. 8 hydrogens are there. So, what is the organic compound? What is the organic compound? That is C6H8. That is. Okay, na? What is its du? Compared to alkane, how many hydrogens are less? We are following this formula, your choice. Then format 1. 1. C6H double plus 2, 14. Then I am comparison with alkane, this format. How many hydrogens are less? Here 8 to 10, 2 plus 2. How many? Sorry. This is the 14, na? Alkane. C6 is the 14. How many hydrogens are less? How many hydrogens are less? 2 plus here 4. 6 hydrogens are less. 6 hydrogen means by 2. What is the du value? Du equal to 3. So this is very difficult. I want to follow formula. Okay, you format 2. Du formula equal to 2n plus 2. 2n plus 2 means what is that? That is 14 minus number of hydrogens 8 by 2. Then here what is the value? This is 6 by 2 equal to 3. Okay. For this one, answer equal to 3. Okay, na? Next one. In Carius method, the estimation of halogen, that is 0.25 grams of an organic compound give 0.15 grams of silver bromide, and the percentage of bromine in the organic compound is 10 power minus 1 percentage. So, what is the reference? We want bromide, no? For bromide, percentage of bromine, reference unit equal to AgBr. AgBr. Chloride, AgCl, bromide, AgBr, and iodine, AgI. Now, percentage of Br equal to what is the reference? AgBr, na? This is, this weight equal to 80 by, that is AgBr weight equal to how much? Ag 108, Br equal to 180. Therefore 188. Therefore 188 into weight of AgBr by weight of organic compound into 100. Okay, this is the Carius method. Therefore 80 by 188 into 0. How much is there? That is the organic compound silver bromide 0.15 by 0.25 into 100. Clear? This is a 15 is a 25 is a 3 by 5. Therefore 80 by 188 into 3 by 5. Okay, na? This is 16. This equal to 30 plus 48. Okay, na? By 180 into 100. 100. This equal to here. This equal to 48 by is a 1.88. Clear? This is around 25.53 is equal to around 255. Okay, na? Into we want a x value into 10 power minus 1. This is a percentage. Okay, na? So answer is a 255. Clear? Thank you.
Brilliant Study Center, India's #1 coaching center for NEET and JEE.